With a function, we can talk about the domain and the range. What are those? The domain is all the x values. And what is a range? Range is all the y values. If we have a graph, this is a graph of a function. What does it take to be a graph of a function? You pass the vertical line test. So I'd only intersect one place, one point, or no points if I scan through the vertical line. So we're going to look at domain and range of this function right here. So we'll do domain first, all the x values. So what do we have? We're going to start at -3, and we have all the x values until we get up to +1. So how do we write that? Here's the domain. We're going to use interval notation. So we're going from -3 to 1. So we're writing at -3, 1, and it's okay to equal -3. So we're going to go closed at -3. For +1, this is empty right here. So it does not include the endpoint. So we're going to go from -3 to +1, and we're not including the endpoint. So that's the domain. Range, similar, except we want to think about y values here. So what y values do we go between? Yes, we do have -1 y value right here, but we go all the way down to -3 is really the smallest y value. And we go up to +4. So we're going from -3 to +4. We can equal -3. So we go closed at -3. Now +4 is up here. We don't actually hit +4. So we're going to go open at +4. Now these are intervals of, these are x values. So this is an x value interval, and this is a y value interval. So these are not going to be points, these are going to be intervals of x values and y values. That's the domain and the range. There are other ways to determine if a function, if an equation is a function, represents a function or not, and we can do that using algebra. So here we have x² + y² = 1. Is this a function of x? So without drawing a graph, what we can do, if we can solve for y, if we're successful, so we get y equals a function of x, an expression of x, then we can say y is a function of x. So let's try that. We're going to try to solve for y. How do we solve for y? I like to think about solving for y as getting rid of all of y's friends. So what friends does it have? It's got a +x², and it's got a squared right there. Now this is PEMDAS. When you're doing arithmetic, you always go downwards here. When you do algebra, you can go either way. Generally, when in doubt, go upwards. So take care of addition, subtraction before multiplication, division, before exponents, and then finally parentheses at the end. So we got no parentheses here. Do have exponents, don't have multiplication, division, and I do have addition, subtraction. So we're going to take care of the x² first. How do we do that? We're going to subtract x². So we get this, we're just subtracting x². It's absolutely okay to write the minus x² minus x² on both sides. That's absolutely okay to do. I'm going to skip that just really to save time. Once we're here, now what do? I just have to get rid of the squared. How do we get rid of a squared? I do the opposite, which is a square root. And we have 1 minus x². But remember, y, if you square it, if it was negative, it would become positive automatically. So you lose the fact that y can be positive or negative. So when you take a square root of something squared, you get plus or minus. Now, how do you think about these? You should think about it the same way your brain is saying them. So you either get y equals positive square root 1 minus x², or y equals negative square root 1 minus x squared. So did we solve for y? If you knew what x was, unfortunately, I would know either what y is as a positive or a negative value. So if you told me x was 0, to keep it simple, we would have 1 minus 0 is 1, square root is 1, and over here we get the same thing except it would be square root of 1 negative. So you would say if x equals 0, then y equals either square root 1 or y equals negative square root 1. So you would either get 1 or negative 1. This breaks the function rule. So right here, because we could not solve for y, what that means is there'll be some x values, and it only takes one x value that has two different y values. So we couldn't solve all the way for y. We got a plus or a minus. Because of that, we're not a function. Function notation. So this is 1.4. It's very important to get the notation correct